And our next speaker will come from Bashkiria. This is a Russian republic. Shaikhil Islam Kutushev. He will speak about digital photogrammetric technologies in Bashkiria.
Hello, dear colleagues. First of all, on behalf of Bashkiria 30,000 staff university, let me express my thanks to Rakurs to invite me to take part in the 12th International Conference. The Bashkortostan University makes sizable contribution to the Republic. Our area size is 0.8% of the size of Russian Federation. Bashkortostan is a well-inhabited part of Russia. Some important and vital road and railroad infrastructure goes through the Republic. Besides, we are part of Ural Economic Zone, and it borders on well-developed parts of Povolzhia. Geographically, Bashkortostan is located on the hills of southern Ural. At the moment, we are not well supplied with relevant plans and maps. What we have is quite obsolete. This fact creates certain difficulties in developing socio-cultural, tourist and other fields of economy. Therefore, within the national targeted program, creating automated system of maintaining the state land cadastre and listing of sites of real estate for 2003-2012, resolution of the government number 398 was adopted, seeking to create orthophoto plan in 1 to 10,000 scale for the whole of Bashkortostan Republic. For this purpose, the following organizational technological scheme was approved: aerial photography, georeferencing, point crowding, digital elevation model, creation of orthophoto plans, and applying additional layer of information from the cadastre. Aerial photography was made in 2008. The flight scale was 1 to 40,000. We used Hasselblad H4D camera with the lens HC 80mm and focal length of 153 millimeters. It had the automatic shift compensation feature with the focal length of 153. To locate centers of projection during aerial photography, we used the two-frequency GPS locator. The overlap was 60 and 30% along and across accordingly. The ground control points were georeferenced using satellite geodetic equipment. Geodetic measurements were made in fast statics mode. Preliminary processing of satellite imagery was done using Trimble Geomatics Office software in the field. After daily transposition of data from receivers into computers, GCPs were selected so that the accuracy is maintained within 0.1 millimeter. We use GCPs such as local objects, separate trees, not higher than 1.5 meters, fences, roofs. GCPs were attached to special magnifying glasses with 7-time zooming. The description of ground control points was provided. The control of recognition was made by the second survey using free aerial photography. Aerial imagery was made similar to main recognition. Quality assurance was provided. The control included periodic verification of PDOP values, which did not increase the value of 4. We used a block layout of 1 to 120,000, and that data was from 2008. We used the frame of reference, the system of coordinates of 2002. The copies of reproductions of block layout used the blocks with vertical GCPs to make sure that they cover the whole territory, including all overlaps. It provided periodic verification of records of epochs to make sure there are as few disruptions as possible. As I said, we used the Geometrics Office software. The RMS error did not increase 1 meter. Digital orthophoto plans 1 to 10,000 were created in the system coordinates MSK 0.02 for the entire area of Bashkortostan. Digital orthophoto plans were created using 1 to 40,000 aerial photography images. Crowding of the GCP network. We, for this purpose, use the photogrammetric station photo mode using the following algorithm. Area negatives scanning, photogrammetric crowding of GCPs, creation of DEMs, orthophoto transformation, orthophoto imaging in the scales 1 to 10,000. We also recorded DVD discs with orthophoto plans. Source data 1 to 40,000 images, focal length 153 millimeters. Images collected in 2008. We also used projection centers from images made with 1 to 10,000 scale. The scanning of negatives was made using Delta scanner. The frame size is 23 by 23 centimeters. The ground GCM was 0.48 meters. Photogrammetric condensation was made using photo mode. The content and scope of works were in compliance with photogrammetric works needed to create digital topographic maps and maps. The creation of the project was made using photo mode module montage desktop. Further processing was carried out using photo mode AT. The accuracy for internal positioning did not increase the elements of geometric resolution for scanned images. Area triangulation was done by measuring coordinates of tie points collected from 6 standard zones. The optimum number of measurements in each zone was 2 to 3. The RMS for residuals did not increase 10 micrometers. Maximum value of residual cross parallax was 20 micrometers. Accuracy control in triplets was RMS error 15 micrometers, maximum value 33 micrometers. The average size of residual parallax for stereo pairs was 4 to 5 micrometers. Maximum error value for parallax was 11 micrometers. The adjustment of photogrammetric networks was done using the local coordinates MSK02 in photo mode solver. As a result of triangulation, average errors for vertical positions in GCPs did not increase 0.2 millimeters in the plan scale and at checkpoints 0.3 millimeters. The adjustment accuracy is in full compliance with photogrammetric regulations. Digital elevation model construction. The generation of DEM was done using photomod DTM, using pickets and structural lines. In generating DTM, automatic and manual modes were used in various combinations. Depending on the nature of relief, the spacing of regular network varied depending on the site and stereo pair. Such sites as ravines, cliffs, roads, and other elements were reflected as structural lines. We applied pickets to various locations. The elevation accuracy was 4.6 meters according to specs. The regular height matrix was built using 10 millimeter spacing in photomod montage. Orthophoto plans were creating using nomenclature sheets that apply to Bashkiria Republic. The scale was 1 to 10,000. System of coordinates MSK02. We used TIFF format and we used TAP referencing files. The analytical transformation of negatives was done within the bounds of useful area of images. Cut lines did not cross the reference points. When those did cross, the cut lines applied in a direct angle to the site. The average values of errors did not increase 0.5 millimeters. The mismatched contours, line contours, did not exceed 0.7 millimeters. In generating orthophoto plans, adjustments of brightness was performed using local adjustment. Phototone adjustment of fragments was performed as well using automatic approach. After generating orthophoto plans, we cleaned images, removing dust and other alien particles. For that purpose, we used dust correct application. We carried out visual verification of quality for cutouts. Accuracy control for mosaic generation was used with points, crowd points that were not used in transformation. We use digital photogrammetric system photomod montage for this purpose. When we recorded the material on a DVD, we used TIFF format. Each DVD disc was labeled properly. Application of cadastral information from state cadastre on orthophoto plans. The source material were materials 1 to 10,000, MSK.2. Schemes of co-location of cadastral quadrants, normalized electronic tables, and local systems of coordinates. The schemes of orientation for the quadrants were obtained from competent authorities. Cadastral information was provided by municipal districts. Quality control. The quality of photogrammetric networks adjusted for GCPs was verified by residuals and geodetic coordinates and on divergence of photogrammetric and geodetic coordinates at checkpoints that were not used in adjustment. The accuracy of orthophoto plans was verified using checkpoints identified during photogrammetric crowding of GCP network at various altitudes. The accuracy of orthophoto plans did not increase items stipulated by paragraphs 4.98.3 of section 2, instruction of photogrammetric works to create digital topographic maps and plans. The information application quality control was performed in accordance with the regulations of the state land cadastre from 2007. The quality control work corresponds to the regulations on control and acceptance 17.004.9.9. The output materials and reporting documents comply with the terms of reference and scope of works. At all stages of production, compliance was verified to see whether they meet the technical regulations. Control organization at all stages and acceptance stages was done by the technical department. The accepted output materials were submitted to the competent organization. So, we managed to obtain nomenclature lists of 1 to 10,000 scale, MSK 02. We use TIFF format, georeferencing files tab. There are 8,260 trapezes that we managed to generate. Cadastral information for various regions of Bashkiria, scale 1 to 10,000, MSK 02, third and second zones, map info mid-MIF format. The results we received meet the instructions of photogrammetric works and recommendations on application information from the state land cadastre for digital orthophoto plans 2.8. The quality of work is satisfactory.
Есть вопросы, готов.
If you have any questions, please go ahead. If not, thank you very much.